pencil. The blue is for the normal side, means the contralateral side, where that I am going to, I'll be plotting an SD curve. If the right side is affected, I will actually do a SD curve for the left side tibialis anterior, because I want to know exactly how that curve is, because I want to know what is the minimum intensity he requires, okay, and how much is the in the next lecture we will discuss Rio based chronaxia and all that stuff, okay. So that and all, how much is there on the other side, so that I can compare with the affected side that how good or how bad the nerve is, okay. So I can predict that. That's the very reason we want a thing. So this I'll be doing it only once at the beginning. Obviously the other side is normal, so I don't have to do it. So what I'm going to do is, can I have a pencil? Normal pencil. Normal pencil. Thank you. So what I'm going to do is this. So this is where I'm going to plot a SD curve. So this is your x-axis, okay, x-axis, and this is your y-axis. Now this is the point where so this is 0. So if this is x-axis, what would be the first duration? Sorry, 0.01. Obviously lesser one, because I see people immediately write 300, so they write here 300, 100, okay. Don't do that, okay. So this is, you are going to write it in reverse. So the first one is 0.01, this one is 0.03, and this is 0.1, and this is 0.3, this is 1, 3, 10, 30, 100, 300, okay, 300. Now I am going to plot the intensity, and intensity, the maximum that I have reached is 30. So I can divide the way I want. This is, I think at least 15 should be there, more than 15 should be there. So I will take 2, 2, 2, 2, okay. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, okay. So it is going to be at least 30, okay. Now what I will be actually writing here is my patient's name, okay, his demographics, basically age and sex, okay, and his hospital number, okay, hospital number, and I'll be writing here what muscle that I did, okay, tibialis anterior, okay, tibialis anterior that I actually did. Now on the other side of the graph sheet, sorry, I take it ulta, okay. So again, all the details that I'm going to write is name, his demographics, okay, hospital number, don't forget, and muscle is with, okay, tibialis anterior, and this is his right side, okay, is affected, okay, right side is affected. And what I'm going to do is I'm going to make a table like, you know, normal mathematics, and what I'm going to do is I'm going to write the x-axis and y-axis and the values of all the x-axis here, starting from 300 to 0.01, and that 300 was we required 3.8, and this is somewhere 29.5. So I'll write down all the values, okay. I'll write I know that x-axis, and that's what x-axis is duration in milliseconds, y-axis is intensity in milliamperes. This is a constant current, okay, stimulator, okay. It's not a constant voltage, it is a constant current stimulator, okay. You can see it in Clayton's 9th edition that there are two SD curves that they would have given. One is constant current, and the other below to that is they would have given constant voltage. Have you seen that book, Clayton's 9th edition? Still no? Please go and see that. They have written very clearly, it is beyond the scope of this textbook, but I can explain you why is it so, okay. I can explain you is it so, okay. Whereas I'll explain you, for you people definitely I'll explain that, you know how it is, why there is a difference. So this is x-axis and y-axis. Okay, fair enough. Now what I am going to do is this, I said that I'll be plotting a graph. Okay, I'll be plotting a graph, and this is obviously the blue is normal side, that is left side, this is left side, okay, left, that is unaffected, and this is going to be your red, that is your right side, which is affected. So once you draw a graph, only once you will draw with the blue, and rest every time that you are going to draw with your left red one, because you are going to compare with the normal, how it is progressing or deteriorating, how it improving or deteriorating, you can compare. That's the reason we want two color pencil. Okay, pencil. Right now it's everything is computerized. Okay. Have you seen that machine which I asked you to see there? No, not it. Not it. PGs? Yeah, the other one. What happened? Okay. Have you? No, not seen. Okay, fine, not seen. Okay. Because there is that machine, no need to do all these things. What you have to do is you have to choose the duration, choose the intensity. Once you are satisfied with that intensity, you just shift to the next duration, next duration, next duration, and once you say that the test is over, it will plot a graph on its own on the screen. Okay, it will immediately plot the graph on its own, and you can memorize with the date. So after 15 days, when you do a repeat for the same patient for the same ID, I can plot another SD curve. It will again save, and it will now compare on its own. It will give you the previous and the present one, and it will tell you whether it is improving or deteriorating. I don't have to sit and do it in a graph sheet. Obviously, that's why it's in lakhs, okay, not in thousands. More try. Okay. Here. See, I need to do everything on your own too. You know, you should do everything, attempt everything on your own. Okay, now what I am going to do is I am going to choose this is the duration, that is 300, 3.8. So 3.8 is coming 300, and this is 4. So 3.8 is here. Yes. So I am going to mark down this. Okay, 1. 100 is again the same 3.8. Okay, and 30 is also I am requiring almost at the same place, 3.8. Now 10 is 4.3. So here this is 4 and this is 5. So in between 4 and 5, so it should be here 4.3. The next is 3 is 4.8. So this is 3, this is 5. So this is here is 4.8 point, and 1 5.4. 1 is here, this is 5, and this is 6. So this is here. Okay, this is here. 0.3 is 7.5. 0.3 is here, and 7.5. So this is 8, and this is 7. So in between these two is your 7 point, midpoint is 7.5. Then this is 0.1, 12.9. 0.1, 12 is here, 14. So this is 13. So here I should have the okay, value of your what? 12.9. 0.03, 19.1. So this is 0.03, and this is 20, and less than that is my, okay, this is my 19.1. 0.01 is 29.5. 0.01, and this is from here I am going up 30, so the 29. Okay, fair enough. So now I have pointed all the things. Yes. Now what I am going to do is I am going to connect all the points. Okay, you can see now I finished the graph. Remember, I didn't extend here and I didn't extend here, because where the point ends your graph stops there. Okay, I see people extending here, extending here, don't do that, okay? Start from the point and end at the point. Don't go a little bit also beyond, okay? Now you can, I plotted the graph. Now if you ask me to interpret this graph is a normal one, a normal graph. Why? Because I started with a steady current and till 1 it was fairly steady. I use the word fairly steady. So in the next lecture I will explain why I call this as fairly steady, not completely exactly steady, okay? Fairly steady. And then from there onwards you can see that this is the left hand part of the graph where it's steeply rising. So this is an innervated curve. This is an innervated curve.